writing is a skill that most of us lose during medical training. And again, it needs a bit of conscious effort to get back into it.
Welcome to Season 2 of the sOOPR podcast. In these conversations, we're bringing you even more insights from successful fellows and advice from leaders from across the UK research landscape. I'm Nikhil Alawalia, and this is brought to you by the British Junior Cardiologists Association in partnership with the BHF CRC. If you like these videos, please subscribe to our YouTube channel and leave your comments below. I'm pleased today to be joined by Dr. Andrew Lewis, who is a postdoctoral research fellow and clinical lecturer and an honorary registrar in Oxford, where he also undertook his PhD in novel techniques for cardiac imaging. He's currently a BHF travel fellow working in Harvard Medical School in Boston in America. So thanks so much, Andrew, for taking the time out to talk to trainees and share your advice with us. Really appreciate it.
So Nikhil, thanks so much for having me today to talk to you. And the BJCA has been a hugely supportive organisation to me through my training, so I'm very happy to share whatever I can that's helpful. That's
great. And I just was wondering if you could take me back to your journey up until your PhD, just so the fellows who are in that sort of position understand how you got to that point and what you think was really influential in your training up till then.
Yeah, I'd be delighted to. So I started my journey in clinical research fairly early on. So back as a medical student, I attached on to an academic clinical firm there, which became the basis for the research I did in my intercalated year. One of the things that really struck me was that I enjoyed having ownership of a longer term project and enjoyed that moment when data started coming in for the first time, which nobody else knew about. And so I enjoyed that and had a successful and productive time with a couple of papers from that. And wanted to continue my research journey towards academic foundation programs. I want to just be clear that I think the academic foundation program isn't a prerequisite at all for future research success. And in fact, I wasn't appointed to the first one that I applied for, though subsequently took a clinical foundation program job in a standalone academic F2 block down in London. And that again was another really sort of formative 4 months. It wasn't what I planned to do, but we worked on experimental imaging for drug development and mechanisms.
Can I ask, at any point in that journey, did you think about coming out of clinical medicine and following this scientist thread?
Yeah, that's a great question. I didn't. So everything I have done in science, I've always linked quite closely back to translational and clinical work. And I think that clinicians and cardiologists have a lot to offer there. It takes a bit of time to embed into basic science labs and to learn a different language and learn new techniques and things. And you learn pretty quickly that the scientists who do that full time are really exceptional people who are extremely good at what they do. And what I've always tried to do is to think, well, okay, well, how can I keep a foot on both sides of the street here? How can you sort of try to be more of a bridge between these amazing sort of basic science advances that you read about, and how can you bring that through to patients too?
Yeah. And so as a clinician in that basic science environment, what sort of unique aspect do you think you bring as the clinician?
So I think if I were to focus on one thing, it would be sort of keeping an eye on the end game and the clinical benefits and the new diagnostic technique or the new treatment that you're going to develop at the end of it. A lot of basic science research is very focused on deciphering new mechanisms, finding a new way to get at something as well. And a lot of funding is directed in that direction. So again, I think I just sort of draw a slight distinction between that very basic science focus and also between the kind of translational work that we can do to bridge that and sort of understand the landscape, see what's coming through, try and think about where that could be applicable for patients and applications down the line as well. So I think that is kind of the space where we can be valuable.
Okay, great. And so then going on to your PhD, how did that idea and project develop?
Right, so it followed pretty naturally from my time in the academic foundation program doing experimental imaging. So again, I'd been pretty set on the power of molecular imaging, sort of PET, MRI and things to understand mechanisms. So again, what I'd initially planned to be doing was the first in human studies using this new technique as of the first in human injections of the new contrast agents that we'd be generating. In fact, you discover that in translational medicine, quite often things take a lot longer than you think, and you've got all sorts of other hurdles that haven't been anticipated and you had to work through. So that phase of it ended up being pushed back towards the end of my PhD. And I spent more time going back into the basic science lab working on some more fundamental work too. So again, it's important to be honest that PhD plans change, and the project that you think you're going to be doing might well not turn out to be the project that you end up doing. And so, yeah, I think you have to be sort of just ready to fail fast, change plans, and if things aren't working out, then realize that the PhD is an amazing opportunity. You've got your salary basically paid for 3 years. You've got the whole of the resources of a university open to you, and you go and find something else that's interesting to do and works along with the same sort of program of work and all fits into a thesis. So I think I would say just recognize when you've reached the limits of what you can do on one thing and when there's going to be a delay, and be flexible, willing to go and try something different for a bit and learn some new skills.
Yeah. And so how did that influence your research after your PhD? Because I think one of the big things that I saw on your Twitter page was you did this really incredible experimental imaging work in patients with HFpEF. And how did you work in the sort of the uncertainties and the unpredictabilities that you learned about during a PhD into your planning of that next project with your team?
Yeah, thanks very much for that. So this was it was a really interesting and fun project to run. Again, it was sort of pretty de-risked compared to the previous molecular stuff I'd worked on, because it didn't rely on expensive molecular imaging techniques. This was sort of based on techniques that we had available in the departments. The idea of sort of trying to image pulmonary congestion and link that back to cardiac energetics is really an idea I sort of wondered about years earlier back in the academic foundation program. It's something we tried to work on back in that imaging center, but we've never had the MR hardware or capability to do it. The scanners just weren't fast enough to kind of do the real-time imaging and reconstruction things that we needed to do that. And so for that project, it was a case of starting off with the idea of sitting down with coffee and bouncing it around a few trusted supervisors and mentors and thinking about how it might look, and then thinking about what sort of assets could we put together to do it. And we were, again, just right place, right time stuff that we were lucky to have just had a collaborator who'd purchased an odometer so we could exercise people in the MRI scanner. We were lucky that we just had a new MRI scanner that could do this real-time imaging during exercise that we needed to look at the whole heart. We were lucky that we had these established energetic imaging techniques that we've been using for years and we didn't need to modify. And then we just had this idea of putting it all together, and we thought, well, all we really want to try and do is link it back into patient symptoms now. We'll try and do that with some pulmonary congestion, lung water imaging, and that was a new development that we needed to add to it.
You're saying right time, right place, and talking about luck, but I wonder how much of it was just sort of strong foundations that you'd set up within your unit, because you obviously knew what was being set up, what was being worked on, and who to reach out to for help at the right time. So how important do you think it is to develop a network?
Yeah, I think it's another great point. And the longer I spend in this game, the more I realize that networks are just super important to how you do this. I mean, trying to do a modern science project is almost never going to be a solo endeavor, and you're going to need to pull expertise from different parts of the university, different universities all together, in fact, to make things happen. And so I think that the more time you can spend networking early on, learning about what other people do, taking some time to engage with them, to understand their world and things, that makes your life so much easier when you then need to come back and say, okay, this is the thing I need. And then you know exactly who the right person to approach. And so having that contact and that trust and that network and collaboration is just is super important. And it really takes time to invest in it.
Okay, so I now want to talk a bit about communication and writing, because that work that you did, it was a pretty complicated topic to me, but I think you communicated it pretty clearly in a paper which you were last author on in Circulation, and also you've got a very good Twitter thread of a summary of it, which I can put the links to at the bottom of the video here. And going back, the reason why I reached out to you was because Chris, our president at the BJCA, recommended you because going back to 2017, you were the BJCA Starter Writing Prize winner. And so I want to get your thoughts on how much conscious emphasis you put on writing and communication and clarity, and how much of it you think is something that just, again, worked out for you.
Sure. Well, writing is one of those things that definitely doesn't just work out. It's something that, when you get to scientific writing, everybody finds it difficult. And it takes a bit of time to come to terms with, doesn't it? Because as cardiology registrars, we write thousands of words a week in clinic letters without thinking about it. And they all kind of turn out okay, and you send them out. But for scientific writing, it's a very different ball game that takes a lot more time and energy to get into. And it's a much slower process. I mean, when I was writing my thesis, I was pretty happy if I'd got through about a page in a day, something like that. I've been trying to think about some tips I can pass on to some of the new cardiologists coming through who might be listening to this video. So I guess first things first, just acknowledge that it's going to be difficult and you're going to have to invest some time to do it. But equally, I think it's a skill which you can learn. The more you do it, the quicker and the easier and the quicker and easier it gets. There's sorts of things I have learned the hard way to do are that you have to sort of block out a decent amount of time, like a morning or an afternoon. Try and remove distractions, so switch off notifications on emails, phone, whatever else. Try and start with a really clear plan, try and figure out what you're trying to achieve by writing this, and that will be different depending on whether it's a grant where you're trying to convince someone to give you money, or it's a paper where you're trying to communicate an idea clearly, or it's an essay where you're trying to sort of be a bit provocative and start an argument, as I was back in the case just then. And so having said about some time, then structure it out. And I think the other thing that's important to say is that it's great to just get something down on paper, just write something, and then spend a bit of time coming back to it over the next few days to get it into the final situation. Generally, I think if you can say things in a shorter, more concise, clear way, then I try and do that. Lots of scientific writing is pretty impenetrable, and I don't think that necessarily reflects well on the writers. I think a lot of the best scientific writing you read is stuff that's not necessarily in your own field, but it's so well written and clear that you can go back to it and you can understand the premise of the argument that people are trying to make. So if I were to sort of summarize a few tips there, it would be to set aside a decent amount of time, be very clear about what the goal of your writing is, then just write it, wash, rinse, repeat, and keep on coming back to it and making it shorter and shorter and clearer until you're happy with it. So that's my approach.
So for your thesis, let's say, how much time did that take, and what was your approach to doing that? Yeah,
again, thesis is just a very long, slow bit of writing. I tend to suggest people block out between about 4 to 6 months to write a thesis, something like that. Yeah, so that was just a long, difficult and slow process. Again, it's quite fun when you get in, once you sort of really get into it and you start sort of entering that phase that authors call flow, where you sort of block out the distractions and words actually start appearing on the screen. But I think most people just find that a difficult and challenging time, even though they're pleased with the results at the end of it.
Okay.
For writing theses, actually, one additional tip I would make for anybody who's going through this stage at the moment is to block out some time to go on a proper long documents course, which most universities will offer. And look, we all know how to use Microsoft Word. It's easy to bash out a letter here or there, but for long documents, there are definitely all sorts of tips and tricks that you can learn from the software that will save you so much time towards the end of the document when it's becoming 200-300 pages. So that's a day or two well spent.
Okay, I guess GCSEs onwards, you're, as a medic, sort of reinforce this idea that numbers, maths, multiple choice questions is the way you're assessed. And so you're not really taught about how to write papers. Do you have any sort of relevant, sort of related advice or resources or courses that you recommend?
Yeah, I guess firstly, I agree entirely with your assessment about I think writing is a skill that most of us lose during medical training. And again, it needs a bit of conscious effort to get back into it and some time and investments to get your skills where you want to, because it is a learned skill. I think what I would suggest is a good starting place is to read a lot, actually, and to sort of think about where your where your paper is going to end up, because that's going to look different if you're writing a case report compared to if you're writing a basic science manuscript or a clinical investigation. So spend a lot of time reading as much as you can in the area will teach you about the formatting, the sort of the styles of the journals that you might be writing for.
Do you think it goes further today with using social media as well? Do you think that the scientist and the researcher has a responsibility to share their message wider?
Yeah, I definitely do. So I mean, yeah, with the lung water energetics paper, then this was the first time I kind of tried writing a tutorial on these sorts of things. I was really surprised at how long it took us to put that together. Actually, it took at least an afternoon to come up with 10 or 15 tweets to do that with the figures too. But again, the results from that are pretty tangible, actually, because you see there really is a lot of engagement, and then if you sort of follow the metrics and things, you can look around the world and see who's following your treat thread and opening a manuscript. So it was in the day after we posted that, it was much the most accessed journal article that I have written so far. So definitely, again, another different skill to work on, and another very different style of writing where you're trying to communicate ideas in short tweets instead, with some supporting figures. But yeah, I think, again, the more you can simplify, communicate, make things clear, then the better.
And did you build up your network at all because of that, or did anyone reach out to you as a result of sharing any of your information online?
Yeah, it definitely does help to build a network. And again, we've had several contacts from collaborator requests and contacts with the reviewers, with the editorialists as well on the work. So yeah, that is all super important for networking. And it's yes, I'm going to sort of work on, reflect on, try and get a bit better at, but I think I'm convinced by the potential benefits of that approach.
Great. And now, before we finish, I wondered if you had any pieces of advice that you wish someone had told you right at the start of all of this.
Yeah, so I think first and foremost, I'd say, look, just don't be disheartened if things don't work out along the way. So I've definitely had applications along the way which haven't gone the way I've wanted, and a lot of the career moves I've made have been sort of chance encounters that happened at quite short notice, but never regretted taking one of these opportunities, and never regretted taking a path which wasn't necessarily the path of least resistance. So there are all sorts of routes into PhD funding and research. Think carefully about the areas you want to work in, spend some time to talk to the current fellows, spend some time figuring out about what you sort of really want to look for in your supervisors. And then, yeah, I think just start early. It's never too early to start looking for cases that you can write up, or people that you can connect to, or research that you can contribute to. And the earlier you do that, then the easier that makes things downstream. So those would be my general tips. And if there's anybody wondering about that, if you want just to reach out and talk a bit more, then very happy to do so.
Great, thank you for that. So thanks again for taking the time, and I'll include a link to your papers and actually also to your BJCA Starter Essay Prize in the links at the bottom of this video. So thanks again, Andrew.
That's my pleasure. That essay was great fun to write all those years ago. Some of the concepts in it now definitely haven't aged well, and were and have not withstood randomized controls trials that came since then. So people are welcome to keep that in mind. But it was a very fun opportunity.
Join us next time on the podcast for.
But the world is full of optimists. So one of the jobs of the statistician is to rein in the enthusiasm of the cardiologist.
I'm joined by Professor Stuart Pocock, who is the Professor of Medical Statistics at the London School of Hygiene and Tropical Medicine. Professor Pocock has collaborated on some of the biggest cardiovascular trials over the last decade. He talks to me about the importance of collaboration for success, the initial statistical considerations when designing a study, and what it's like working as part of a bigger team.